So now we will talk about this digital power system stage 4. So this stage existed approximately from the year 2000 to 2010. So students, the beginning of the 21st century brought tremendous advancement in the computers, digital electronics, communication technology and the internet. These technologies were not limited to mobile phones and computers. They also started transforming the electric power system. Instead of depending completely on manual operation, utilities began introducing digital technologies into power generation, transmission, and distribution. This process is called the digitalization of the power system. So, let us understand this with an example. So, think about banking. 20 years ago, people visited banks for every transaction. Today, we use mobile banking, internet banking, and UPI. The bank is still the same, but the way we access banking services has completely changed because of digital technology. Similarly, the power system still generated, transmitted, and distributed electricity, but monitoring and control became digital. So, now let us see what new technologies were introduced during this stage. So, first is the digital substation. First is the digital substation. So earlier, most substations used analog meters, manual relays, and conventional wiring. So during this stage, digital substations were introduced. These substations used digital protection relays, microprocessor-based controllers, and digital communication. So as a result, monitoring becomes faster, more accurate, and more reliable. Then the second technology advancement was the communication network. Communication network. So students, imagine trying to operate WhatsApp without the internet. So, is it possible? No. Similarly, all intelligent devices in the power system require communication. Communication networks connect power plants, substation, control centers, and utilities, allowing them to exchange information in real time. So, without communication, modern smart grid technology cannot function. Then, the third technological advancement was the smart meters. Then, the fourth technological advancement was automated automated protection. So earlier engineers manually inspected equipment after fault occurs. So during this stage automatic protection system became more common. Protective relays could quickly detect faults, trip circuit breakers, and isolate the faulty section. So this significantly reduced the damage of electrical equipment. Then the fifth technological advancement was geographic information system. So, students, have you ever used Google Maps? Google Maps tells us the exact location of roads, hospitals, and restaurants. Similarly, utilities uses a geographic information system to know the exact location of transmission lines, transformers, substation, and distribution feeders. Suppose a transformer fails, so with the help of GIS, engineers can immediately identify its location and reach it quickly. So GIS improve maintenance planning and fault management. So the digital power system is the foundation for the smart grid. So it introduced digital monitoring, communication, automation, and computerized control. Later, these technologies were further developed to create today's smart grid. So, we will understand the characteristics of digital power system. So, the first one is the digital monitoring characteristics. So, first one is the digital monitoring. So, instead of manual inspection, engineers could monitor equipment using computers. So, voltage, current, frequency, and power flow could be viewed on computer screens. Then, second characteristics was computerized control centers. Computerized control centers. So earlier control rooms mainly depend on operators. Now computer become the central part of the power system operation. Engineers could monitor thousands of electrical parameters from one location. Then the third characteristics was the communication network. Communication network. So power plant, substation, and control centers become interconnected through communication network. So this allowed faster information exchange. Then the next characteristic was the remote meter reading. So instead of physically visiting every consumer, utilities could collect meter readings remotely. So this reduces manpower and billing errors. Then the last characteristic was the automation. So many repetitive operations become automatic. So this reduces human error and improves system efficiency. Now we will discuss the advantages of this stage. So the first one is the faster fault detection. Faster fault detection. So earlier finding faults could take several hours. Now the digital devices immediately inform engineers about the abnormal condition. Then the second advantage was the better asset management. Better asset management. So an asset means equipment like transformer, then transmission lines and circuit breakers. So digital system continuously monitor their condition, helping utilities perform maintenance before failure occurred. Then the third advantage is the improved operational efficiency. Improved operational efficiency. So since computers handled many routine tasks, the entire system operated more efficiently. Then power interruptions reduce and decision making become faster. And the last advantage was the reduced manual intervention. Reduce manual intervention. So many operations that previously required engineers to visit substations become automatic. So this reduced both manpower requirements and operating costs. Now we will discuss the limitations of this digital power system. So first is the limited consumer participation. Limited consumer participation. So consumers still remain passive users of electricity. So they had very little interaction with utilities. Then second limitation was distributed generation was minimal. Distributed generation was minimal. So today we see rooftop solar panels everywhere. But during this period, distributed generation was still very limited. The system mainly depends on the large centralized power plants. Then the third limitation was the no self-healing capability. So suppose a transmission line developed a fault, the system could detect the fault, but it could not automatically restore supply by rerouting power. So engineers still had to take corrective action. So this capability was introduced later in the smart grid. Then the next challenge and the next limitation was the cybersecurity challenge. So as computers and communication networks become the part of the power system, a new challenge appeared, that is cybersecurity. Earlier, the biggest threat was the physical fault. Now the hackers could potentially attack computers networks. Therefore, protecting the digital communication become extremely important. So, students, the digital power system solved many problems, but utilities wanted even more. They wanted automatic fault restoration, consumer participation, renewable energy integration, electric vehicle charging, battery storage, artificial intelligence, and two-way communication. So, all these requirements led to the development of the smart grid, which is the fifth and final stage in the evolution of the electric power system.